Welcome to episode 44 of the Snowflake Snowpro Core Certification in-Depth Training Podcast, brought to you by BrightFlux. I'm your host, Yaqub Abdul Hakim, a certified Snowflake user, and today we're diving deep into scalability policies and modes in Snowflake. This episode is designed to thoroughly equip you with the knowledge you need to excel in your certification exam, focusing on a crucial area for any data professional working with Snowflake. First, let's break down what scalability in Snowflake is all about. Scalability in the context of Snowflake refers to the ability of a Snowflake environment to accommodate larger or smaller amounts of data processing load automatically or on demand without compromising performance. This is made possible through Snowflake's multi-cluster shared data architecture, which separates compute and storage resources, allowing them to scale independently. There are two primary types of scalability in Snowflake: vertical and horizontal. Vertical scalability, also known as scaling up or down, involves changing the size of an individual compute cluster, essentially adjusting the compute resources like CPU and memory available for data processing. On the other hand, horizontal scalability, or scaling out and in, implies adding or removing compute clusters to a virtual warehouse, thus modifying the parallel processing capacity. Snowflake provides several modes to manage scalability. 1. Auto scale. This mode enables automatic adjustment of compute resources based on the current workload demand. It allows Snowflake to dynamically add or remove compute clusters to a virtual warehouse, ensuring optimal performance with efficient resource utilization. 2. Manual scaling. In contrast to auto-scale, manual scaling requires users to adjust compute resources manually. This approach gives users more control over their computing costs and performance, but it demands a solid understanding of the workload requirements. 3. Multi-cluster warehouses. Snowflake supports creating multi-cluster warehouses, which are essential for achieving horizontal scalability. Here, users can specify a range of clusters, minimum and maximum, that can be automatically managed based on workload demands, offering a balance between performance and cost. Understanding these scalability policies and how to manage them effectively is key to optimizing your Snowflake environment for both performance and cost. It's crucial to analyze your workload patterns to choose the most appropriate scaling mode and warehouse size. Now, let's explore some best practices for implementing scalability policies in Snowflake. Always monitor your workload performance and query times to make informed decisions regarding scalability adjustments. Consider using auto-scale mode for unpredictable workloads, but set clear boundaries to control costs. For predictable workloads, manual scaling can offer cost savings by optimizing the compute resources according to a fixed schedule. Utilize multi-cluster warehouses to ensure high availability and fault tolerance for critical applications, especially during peak usage times. By mastering these concepts and practices, you are well on your way to excelling in your Snowflake certification exam and effectively managing scalability in your Snowflake environment. That wraps up today's in-depth look at scalability policies and modes in Snowflake. I'm Yaqub Abdul Hakim, wishing you success in your exam and beyond. Remember, with knowledge and the right tools, you can achieve outstanding performance and efficiency in your Snowflake projects. Thank you for listening to the Snowflake Snowpro Core Certification in-Depth Training Podcast. We'll see you in the next episode, where we dive into another critical aspect of mastering Snowflake. Goodbye for now.